Hello, and welcome back to our series on building a web server from scratch using C++, and I'm happy to report that our bug has been squashed. I have dealt with him most severely. So let's talk about what the bug was first. Now, you're going to notice that these files look quite different from they did the last time, and that's because I did a certain amount of work off camera, and all of that is pretty much just aesthetic, except for the bug fix. I just added some comments in here just to make things a little bit more clear and make it more aesthetically pleasing to look at. So other than the bug fix, these are just aesthetic changes. So let's talk about the bug fix itself. The problem was right down here when I was calling the listen function. So let's first look at, well, what I was sending it was get binding rather than get sock. And if we check out the manual pages, we will see that the bind function returns 0 on success, or -1 if it doesn't work. So when I was actually printing out the result of that, it was printing 0. And so it was returning success, even though what this listen function needs is actually the socket file descriptor. So when we call socket up in simple socket, we get a file descriptor for the new socket, and that's the value we needed to pass into listen. So it's working now, and the reason was I was calling get binding instead of get sock. Now, I don't actually know what this file descriptor means. So I know that in this case, I was able to print out what it was. It's 3, but I don't know what 3 refers to. So if you know the answer to that, please leave it in the comments. I would love to know. But we've got everything working now, so this class is complete, for now at least. And I also want to point out that I removed something in binding socket. I was storing as a member variable the connection from connect to network, and I had a function in simple socket called getConnection, and I never referenced this. Never referenced connection. I never used the getConnection function, so I just took it out completely. So now all we have is the socket and getSock, and we use getSock in listening socket in the listening function, and that solved our problem. Okay. So today we want to start building the server objects, and we will once again refer to our friend Skrew Everything and how he implements the server. And what we can see is that this is a several part process. All of it takes place inside of this infinite loop. And the infinite loop does a few different things. Well, first it prints out that it's waiting for a connection. Then it creates this new socket with this accept function. New socket is defined up here as an integer, and let's see, where'd I go? There it is. It tests that connection to make sure it worked, and then it reads that connection. So it's basically the client is making a request to the server, and right here it is reading what that request is. Then in this example, it is just being printed to the screen, and then it is writing a response, which in this example is just hello world, and then it closes the socket. And there are a few things that we're going to want to do here. First is accept the socket and read what it is saying. Then we want to handle the request. So we're not going to use a print statement. We're going to want to do something specific depending on what the client is asking for. Then we are going to write that response, or whatever the result of handling that request is, back to the socket, and then close that socket so that the next connection can be handled. And all of this is going to take place inside an infinite loop. Now, just as I did with the socket objects, I'm going to start with a very general simple server, one that has virtual functions that the children are going to have to implement in some way. So I've created a server folder, and let's create our first class. It'll be simple server. And I'm going to go into the header file, and we're going to need to include our socket objects. Now there are two ways I can do this. I can include dot dot slash to go back a directory. So now I'm in my networking directory. And I can include just the socket that I need. So I can say sockets slash listening socket.hpp, or I can include my top level header file, hdelibc networking. And I think that's the one I'm going to include in case I want access to something else from it. So let's go ahead and use our namespace. It'll be HDE. And our declarations, class, simple server. And here is a question. So simple server. Is a server a socket, or does a server have a socket? This is the is a versus has a question in object-oriented programming. So if you think of a rectangle and a square, a rectangle has a length and it has a width. But to say that a rectangle is a length or that it is a width does not make sense. Whereas with a square also has a length and it has a width. But to say that a square is a rectangle actually does make sense. So that's when we would say that the square is a child of the rectangle. And the question here is less clear. So is a server a socket? I could probably be convinced that that is the case, but you would have to do the work of convincing me. So I'm going to go under the assumption that simple server is not a socket. It has a socket. And we'll probably want that as a private member. And we'll also want at least a constructor. Now here's a problem. I want to define our listening socket in our constructor because I'm not going to know for every server what is the proper domain protocol, sign family, all of these different things that we set up. I still don't know what those are going to be. I do know what they are in the case of the server I'm trying to build, but what I'm making right here is a general simple server that can apply for any server. So here, I don't actually know what those are. So I'm going to need to pass them into the constructor. But I want our socket to be a private member variable. And the only constructor I have for a socket requires those parameters. So what I'm going to do is use a pointer. I will say, not simple, but listening socket. I'm not getting autocorrect, which always worries me. I'm going to say listening socket, and I'm going to make it a pointer, and I'll call it socket. So this just defines a space in memory to hold a socket without actually instantiating it. That way, in simple server, I can pass in as arguments all of the parameters for our sockets and then define the actual socket. So let's pull up the not that. Let's pull up our listening socket header file so I know that this will be passed domain, service, protocol, port, and backlog. And then let's go into let's move our header over here, and let's open our definitions, and we'll say HDE simple server. I'm not getting autocorrect, which usually means something is not going right. So give me 1 second. I'm going to restart and see if I can actually get those those autocompletes. Okay, we're back. It's good now. Sometimes it just does that. I don't exactly know why, but restarting it tends to fix the problem. So we're going to pass this in domain, service, protocol, interface, and backlog. Okay, and in here, I want to set the socket member variable to have a value of an actual socket. So let's say socket equals new, and this is how I'm going to put something in there. And we'll call it listening socket. And we're going to pass it domain, service, protocol, port, interface, and bklg. And here is where you need to worry about something called a memory leak. Now, what I'm doing here is I have this null pointer, and I am instantiating a new listening socket object. And I'm putting that listening socket object into this memory location, or I'm pointing the memory location to that new object. And let's say later I do this again. So let's come down, and just as an example, let's say I want another one. So I say new listening socket, and I pass in different parameters. What I have done is pointed this pointer towards a different object, without actually clearing out what was in this memory location. So what happens is I now have a memory location that I have lost the reference to that is still containing something that I used in the past. So I have no way of accessing that thing again, and it's just taking up space in computer memory. And especially if you do this a lot, you're going to use up a lot of memory in a very wasteful way. So what I would actually want to do is say delete socket. Then I would create the new listening socket in there. And that's how you avoid the memory leak. But in our circumstance, this socket is going to exist for the duration of the server's life. So I don't need to worry about the memory leak here. I just cannot responsibly show you this new function without telling you about the memory leak. So we're good for now. Okay. So what we're going to need are some functions here. And our functions are going to need to, one, accept the new socket and get its request. Then it's going to need to handle the request. And then it's going to need to respond. And all of that is going to need to happen in an infinite loop. And here's the problem. I can see in this example that the request being made by the client is being stored as a character array called buffer. But I don't know if that's appropriate for every client connecting to every type of server. So since I'm trying to build a general object here, I can't specify what these things are going to be or the type. And that means that my functions cannot have return values and they cannot have parameters. So I've come up with what I think is a clever way of doing this. I'm going to define 3 functions in here as virtual functions. So I'll say virtual, and it'll be void. And what do I want to call it? This is where we are accepting the socket. So I'm going to call it acceptor. I don't think I spelled that right, but I'll come back and check. Then I'm going to say virtual void handler, and these need to equal 0. And then responder. Is that going to go away? Yeah, there we go. Okay. So what's going to happen is that when I actually create an instance of a server, it will inherit this simple server object, which will force it to define this acceptor, handler, and responder functions. And the child class can create its own private member variables to hold the request and to hold the response and then to send the response. And they can make those whatever data type they want and implement the actual sending of those in whatever way is needed. And so this allows me to avoid specifying return types for these functions and parameters. So the child can create their own member variables that all of these functions have access to and can manipulate, and that'll make things much easier. So virtual functions there, and the last one I need is our infinite loop. And this is going to be another virtual function. Now, here's where I didn't actually want to use a virtual function. I would rather in the parent class just define an infinite loop that is going to call acceptor, handler, responder, acceptor, handler, responder, acceptor, handler, responder. Unfortunately, I can't do that because if I create that infinite loop in the parent class, it's going to try and call the functions of the parent class. So I have to do that in the child class. So this launch function has to be virtual as well. And this will just be a while loop in the child class that is going to call those three other functions. So the last thing that I think we are going to need in this simple server class is a getter function to get our socket variable out. So I'm going to create that. We'll just call it, it's going to return listening socket pointer, and it's going to be called get socket. There we go. And let's just define it so that it is listening socket pointer HDE. Oh, sorry. There we go. And this is going to return socket. Okay. What is the problem here? Yes. Okay, we need our namespace. Cool. So we should be good to go. This simple server should work as I'm expecting, but now we're reaching a point where I can actually test it. So I'm going to create a implementation class for this. And this is not going to be a class that's really part of the library. I just want to go through the steps of actually implementing and running this so that I can test to make sure everything's working. We've created a number of objects here with no real way of testing them. So this is our first opportunity. So let's try it. We're going to call it test server. And let's open up the header file and the code. And let's define it. So we're going to need to include simple server. And we're going to use our namespace. Class test server inherits a public relationship to simple server. Okay, we'll have private and we'll have public. And let's see what things I need to define from simple server. So private, we're going to have a void acceptor, void, not period. We'll have void handler, and we'll have void responder. And then we're going to need void launch and a constructor. Okay, so that seems good. But as we discussed, the acceptor, handler, and responder are going to need to pass information between these functions using member variables. So let's look at the example and see what member variables we're going to need. So it seems that new socket is going to be created through the accept function, and it's going to need access to address, which we can get. It has address length, which is something different, but we can get that in the function. That's limited to our accepting function. And read is going to be part of the accept. So I don't think we need this val read because it does not come in anywhere else later. And it has buffer. So the buffer in this example is passed into the handler. So in an actual implementation of this, that would not be the case. We would be actually doing something with their request. Unless, in fact, yes, actually, buffer would be going between the classes because the handler would need to know what is being requested. So buffer is definitely going to need to be a member variable. And then it just sends that socket hello. So the new socket is being passed between these functions as well. So we need a member variable for buffer and new socket. So let's create those. So I'm just following the example in Skrew Everything's tutorial, and this is not what I would actually do, so let's just go with it. So char buffer, and it is 30,000 characters, and we're going to set it equal to 0. I don't think that's actually necessary, but that's fine. And then we'll create int new socket. Okay, and let's see. Let's open our C++ file. Say HDE test server. There goes my autocomplete. And acceptor. And that's because I didn't type in void. Okay. So acceptor is going, I keep going the wrong way for these things. Let's put it where I'm actually thinking it's supposed to be. So the acceptor is, we're going to skip the part where it actually tests to make sure everything is working, and we're just going to assume that it works. And bad idea, but again, we're just experimenting here just for the fun of it. So let's say new socket equals accept. And my autocomplete is gone, so I'm going to restart Xcode. It's quite tedious. All right. Accept. And what are we passing it? We're passing it server FD. So I need to get the socket variable out of the socket class from the server class, so the member variable socket in the server class. But remember that listening socket here is a pointer. So this is storing a memory address. And so in order to access a member function or a member variable in a pointer, I need to use a different operator. So I'm going to say socket, and I'm going to use the arrow operator. We're going to call getSock. So that arrow operator allows us to use the member function. We can't use the dot since it's a pointer. And what's the problem here? It's a simple server. Oh, interesting. So simple server, I have my getSocket function. So I wonder if I can call that and just use the arrow. So usually there's no problem stacking up these operators, but this one's a bit strange. I probably would not do it this way in an actual implementation, but I'm curious to see if it works. So let's go for it. And we also need our address equals get socket, and then we want the, yeah, it seems to be working. So we'll get address, nice. And we want to set this as a struct. Is that all working? That seems to all be working. Great. Okay, so we need to do our casting here. So we'll struct and then and then socklen t. How did they do it over here? I think it was a bit different. ADDR length. So we need to actually get the length of it. So, interesting. I wonder if this is poorly done in the article. Not to criticize our friend Skrew Everything. He's helped me quite a lot here. But this seems pretty odd. Anyway, let's continue along. So we want to do size of address. See, there's a lot of function calls going on. Yeah, so let's say Do we want an int or a long here? Probably an int. Yeah, int. Let's just create a new variable. Okay, that should work. Nope, what does it not like? Yeah, okay, there we go, good. So we have accepted the new connection, and what next? Right, we're going to read from the connection. So we'll call read, oh, not that, on new socket. And if I'm not mistaken, we need a new library in here. Yep, read. And which one is that? That one comes from uni standard. So let's include UNI-STD, there it is. Good to go. Read should be available. Ooh, we need that. Okay, so read. Nice. So int is going to be new socket. A void pointer, what is that going to be for? Remind me. Buffer, and then the size of the buffer. Okay, so buffer, and then 30,000. Great. Okay, so that should store the actual request in buffer. And that should be the end of our acceptor function, if I'm not mistaken. The only thing I will want is, no, we'll do that in the actual loop itself. So I'm thinking about these print statements. That way when it's doing things in the console, I will have access to see when it's waiting and when it's done and all of that. But I'll do that in the loop itself. So this is our acceptor. And now our handler, that's going to be easy. We're just going to print out the information. So void HDE test server, and this is going to be handler. So we're going to do standard cout, stream insertion operator, buffer, print a new line, and there we go. What's the problem? Yes. Great. Okay. And then our responder. Okay, and responder, we're going to define this and the close section. So write new socket hello and the string length of hello. So let's just copy the hello from up here. Where is it? And this is not going to be appreciated by C++ because we are converting a string literal into a pointer, and it does not like that. Conversion of string literal character pointer. Okay, that was close. Anyway, so we got hello. It'll still work, so let's not fret about that. And so we're going to write new socket hello and the string length of hello. So write new socket hello string length hello. And then we're going to close new socket. Okay. And now we're going to need our actual launch function. That is the infinite loop that'll be doing these things in succession. And one thing I want to point out about the infinite loop is that when it gets to the acceptor, it seems what it's doing is once it gets to this line where it's waiting to accept, if there's nothing trying to be accepted, then it's just going to wait there and it will be idle. So it's not like it's going to run through the loop constantly. It's actually going to wait, which is really nice. We don't have to do anything to save that space. So let's say void launch, oh, not launch, test server launch. And we are going to do while true. We'll print waiting. And then we're going to call our functions. So acceptor, handler, and responder. And then we'll print. Do we need something else? Okay, we'll print that. Okay, so the last thing that we need is a constructor for this. And this constructor is going to be the simplest one so far, since we, at this point, know what all the information we need is. So we're going to do test server, not acceptor, test server. And let me go back to... So simple server is taking this in its constructor, so we are actually going to pass this along. We don't need void there. So we are going to pass in to simple server af inet. The service is going to be sock stream. Protocol is going to be 0. Our port is going to be 80. The interface was, what was it again? inaddr any, backlog we'll set to 10, and we should be good to go. And what do we want to do? Is there anything we need to do in this constructor? I don't think so. I think we just need to launch. Okay, so if I'm not mistaken, I should just be able to create an instance of a test server. Everything will be put together through this chain of crazy objects, and it should print out waiting, and then we should be able to go into an actual browser and run it. So let's create our main file. We'll just call it test. Okay, there, and we're going to do include test server, not CPP, but HPP. And then we're going to say int main, and we will say test server T. Oh, HDE, we need HDE. Okay. All right. I'm going to compile it, and then we'll run it and see what happens. So give me one moment here. Ooh, what is it happy about here? Ah, this. Glad I saw that. And you can see there are some odd things going on here. Like these no longer exist, main.cpp has been deleted, and this one is talking about our string conversion here, which we're not worried about. It'll actually still do it. We don't care. So I'm going to compile and run it, and we'll check out the result. Okay, so G++ has given us a warning, and that's fine. We were expecting that. And I should be able to run ./test.exe, and it's waiting. So now if I come back over to the browser and I type in 127, and I'm not going to put a port because port 80 is the default. So when I run this, I'm not going to get anything in the browser, but I will probably see, indeed I do. Excellent. So I am seeing right here my GET request from the browser. So this is working exactly as I want. Now the problem is it is sending back this strange hello world message, and my browser has no idea what to do with that. It doesn't know to show hello world or anything like that. It needs a certain content header that I'm not sending. So this server is not useful in that sense, but it does prove that our servers are working. Interesting. I don't know why it just sent a bunch of them. It stopped loading. I don't know. But one thing I also want to try, I'm going to, on this iPad, let's go ahead and start the recording here. Okay, so on my iPad, if I go to my machine's address on the network, I should So if I go to my machine's address, I wonder if I can clear this. No, I can't. Okay. Let's keep an eye on this screen. We'll put them side by side. And I don't know how I'm going to do that in editing, but we'll figure it out. Now, if I go to my iPad, I should be able to see something happening here. No. Let's try it again. Yes, there. Okay, so this is really interesting to me. So if you've ever worked with Python and Flask, you will notice that when you run your Flask application, it's running only on what's called the loopback. So only your local machine can access it, whereas this server is already available on my local network. So if I wanted to, all I would have to do is forward one of my network ports to this machine on the port that this server is listening to, and it would be accessible on the internet. So unlike Flask, this is an actual production server. I can actually use this to host a website. So things are going very well. We have a lot of good signs, and that will do it for today. So I hope you enjoyed the video, and I will see you next time. Toodaloo.